This is section 1.9 on your page 10. We are going to talk about the properties of real numbers. What are real numbers? We will explain the more details later. So just a bunch of numbers you usually deal with it, right? So we are going to talk about their properties. What we are going to talk about is the behaviors of the numbers. So if we know how do they behave, right, then you can manage them better. So a few properties, we use the terms, you get used to it. First one, we talk about inverse property. Right? So, what do we mean by inverse? Inverse means what? The opposite, right? So, what do you think? The opposite of positive is negative, right? The opposite of the addition would be what? Subtraction, right? And for multiplication, what do you think? The opposite of multiplication would be division, right? So, first one, additive inverse means what? We are doing the opposite of the addition, right? Then multiplication inverse is division, which we call it what? Reciprocal. That means if you have fractions, then you reverse your denominators and numerators, right? So let's see. Let's take a look. If I have a 6, what's the opposite of 6? Negative 6, right? If you added them together, what do you have? You have 0. What's the opposite of negative 3? Which would be 3. You add them together is 0. What's the opposite of 1/4? Which would be negative 1/4, right? Then you add them together is 0. So what's the opposite of 0? Itself, right? The things we want you to learn is this one. We start to learn the algebra. So what's the opposite of A? Something we say letters mean numbers. Just represent those numbers, right? That would be what? Negative A. So then when you add together, it will be 0, right? How about multiplication? So what's the opposite of 5? 5 means what? 5/1, right? So you reverse your numerator and denominator, so that will be what? 1/5. Then if you multiply them together, because it's multiplication, you end up with 1. What's the opposite? Inverse of 7/3? That would be what? 3/7. So multiply them together is 1. What's the opposite of 0.5 for multiplication? We say we reverse what? Numerator and denominator. So this one is not fraction. You have to change it to what? Fraction becomes what? 1/2. Then you can do the inverse, which will be 2. Then when you multiply them together, is what? 1, right? If you have a negative 3/4, what do you think? Reverse 4/3, but you need to have what? Negative. Then when you multiply together, still be 1. So how about 0? 0 is what? 0 over 1, right? Reverse become 1 over 0. Can we do that? No. Because we say what? Be a wiser miser, don't use a 0 as a divisor, right? You cannot use 0 as a divisor. Now we want to learn is this one. Start from algebra, we need to learn the variable. So if it's a, means what? A over 1. So inverse will be what? 1 over a. And criteria is what? The denominator cannot be 0. Then when you multiply them, what should you get? Same thing, 1. So first we talk about inverse, right? This one is additive inverse, that one is multiplication inverse. So for all the numbers, for adding and multiplications, they have such properties. They behave this way, right? Then next one, we are going to talk about identity property. So for addition and multiplication, they have such properties, something called identity. 0 is the identity of the addition. Why we call it identity? Because if I add a 0, I adding 0 to a number, right? It doesn't change what? The number's identity. Okay? Change the numbers identity. That means what? 5 plus 0 is what? 5 plus 0, still 5, right? 7 plus 0, still 7. So you keep its own identity. 0 doesn't affect the result of the original number, right? So we call it what? 0 is a special thing. Is the identity of the addition. Okay? So for multiplication, it has such identity, which is what? 1, because look at that, right? So 1 is a special number. So because what? If you multiply by 1, right, to a number, what happened? Same thing, it doesn't change the other numbers value, right? Identity. So what we have is what? 5 times 1 is still 5. 7 times 1 still 7. Right? So 0 and 1 are special numbers, very special. Like computers, they are all built from what? 0 and 1. 1 is true, truth, and 0 is false, right? So they are very special. If you have a 0 and 1, you build a world. Because if you have 0 and 1, right? Then with all the operations, additions and multiplications, then 1 plus 1 is 2, right? You plus another 1 is 3. So you have all the numbers. Everything is built from 0 and 1. Same thing as a computer. Start from 0 and 1. So we build a world with internet and with all the communication and changing world as well. So that's the foundation of the numbers and of the world, right? So we try to understand the numbers better by understanding its property, okay? It also has such characteristics. Let's see. We are talking about addition and multiplication. Subtractions and division is a little bit different. Okay, so we emphasize on these two. First one is commutative, is that right? Commutative property. What does commutative mean? So you commute from point A to point B, from here to there, right? Or you can change from there to here. You're commutative, okay? It means what? For addition, for the first one, if I have 2 plus 5, is that same thing as 5 plus 2? Both are 7, right? So we can interchange, commute with these two numbers. And same thing as multiplication. Is that same thing as 2 times 5 as 5 times 2, right? So we say this one is commutative property of addition. This one is commutative property of the what? Multiplication, right? The things we want to learn is the algebra, which is what? A plus B equals B plus A, right? And for multiplication, you will have what? A times B is B times A, okay? So number can be interchangeable, but not for subtractions and division, right? Another thing number we do is they associate with each other. Those are 3 numbers. How do they associate between themselves? Okay, so if I use a parenthesis, means they are grouping, and we put them together first. So if I have 2 plus 3 plus 5, which one I would do first? 2 plus 3. It's 5 plus 5. I will end up with 10. And if I say, okay, if I do 3 plus 5 first, then I plus 2. 3 plus 5 is 8 plus 2, still 10. Are they the same thing? Right? So if I associate first 2 numbers first, then with third one, or I can associate the last 2 numbers, then associate first one, I end up same. Why do we care about that? Right? So if I have, say, 24 plus 98 plus 2, if I do this one, if I do it first 2, big number, you add 2, right? So, but addition has such a property, we say, oh, okay, why don't we do the back one first? So that would be 100. Then you add a 24. That would be what? 124 quickly. Right? Subtraction will not do it. So, because we say what? 10 minus 6 plus 2. You have to do it from what? Left to right. If you do left to right, that would be what? 4. 4 plus 2 is 6. But if you do the back first, that would be 8. 10 minus 8, that would be 2. It would be incorrect, right? So when you have a subtraction, it doesn't behave this way with associative property. So we need to do it is what? For addition. So for multiplication, how about 2 times 3 times 5? Is that same thing as 2 times 3 times 5? 2 times 3, 6. 6 times 5, 30. 3 times 5, 15 times 2, 30. So they are the same. Okay? So for all the numbers, they have such a property. This property, right? It's called associative property. So we write it in algebra style. That would be what? A plus B plus C equals what? A plus B plus C. Same thing for multiplication. A times B times C is same thing as A times B times C first. Okay? So numbers for addition and multiplication, they behave this way. Another property which we mentioned earlier, here. So it's called what? Identity property. So it's what? 0 for this. 0 is identity of the what? Addition. 1 is identity of the multiplication. It's like 2 plus 0 is 2, right? So 2 times 1 is still 2. And so we write it in algebra style. So it would be what? A plus 0 is A. Or for this one, multiplication, A times 1 is 8. So 0 and 1. Very special. And another one we talk about is what? Inverse property. It's opposite. It means what? 2 plus negative 2 is 0, right? Or if I have multiplication, would be 2/3 times 3/2 would be what? The identity. In algebra sense, that would be what? A plus negative A is what? 0. Or A times 1 over A is what? 1. Right? So we are talking about properties of real numbers, how they behave. Also, you will see something is not on your paper. We call it zero property. Zero property is what? 0 is a special thing. So 5 times 0 is what? 0, right? And 0 times 6 is 0. So 0 times anything, it would be 0, right? So we are going to use this zero property to solve problems later. Another thing is called distributive property. right? So we have plus and multiplication. We write it differently, right? Then on your bottom, we put the distributive property in the middle. Why? Because it relates both of them. Okay, so let's take a look. If I have, say, okay, I have 3 apples and 5 pears, right? In a bag. So if I multiply by 2, I add them together, sum of them together in a bag. If I have 2 times of that much, I have 2 bags of it. What do you think I should have? I should have what? You definitely have 6 apples and 10 pears, right? So you need to apply your 2 to both of them. So same thing as the numbers. If I have a parenthesis with 3 plus 5 in the middle, in a group, right? When we have a group addition, when I multiply 2 of them, that would be what? You add them together, it's 8. 2 times 8 would be what? 16. But if we do it individually like this, I will have what? 2 times 3 is what? 6, right? 2 times 5 is what? 10, right? If I do it individually just like that. But for numbers, if I put them together, do I have the same result? Right? That means when I apply a number to a addition situation, this number needs to multiply everything inside. Numbers, you can just combine them and figure out. However, if we have this situation in algebraic sense, right? That would mean this one, A times B plus C. What's the result if I don't use parentheses? I need to apply my A to both B and C, 2 different things. Then I will write it differently. A applies to B, right? Then also A applies to C. So that means we need to distribute the A to both B and C. So that's called distributive property. This is just behind the information for numbers, and this one actually you are going to use in your algebra. Okay? So also those are not on your paper, and you can see if I have A times B plus C plus D, what do you think that should be? A should apply to everybody. So you should have AB plus AC plus AB. Okay? Same thing if I do it out front, B plus C times A. Same thing, you have to distribute your A back to both of them. That would be what? BA and CA. But you can write AB and AC because by commutative property of multiplication, you can change the position, right? So if I have this one, instead of plus, I have minus. So what should I have? You take care of your sign at the same time, right? So that would be AB minus AC. Next one, if I have a negative B minus C, this is very important and for your algebra. So you need to apply your negative to everybody. Actually, this means what? Invisible one anyway, right? If you distribute your negative sign, it means what? Inside, negative has to apply to b, it becomes negative b. Negative has to apply to negative c. Negative and negative, change. That would be what? Positive c. That means you take the negative out away with parentheses. You need to reverse all the signs inside. Which one is what? Negative becomes this one become positive. Good? Okay, let's look at the next page, page 11. On the top, we describe all the properties. We are going to skip those. Those are not on your homework either. Okay? Then we will continue the next portion. Okay, we are going to learn algebra now. Okay? So, the things we want to learn for all those properties, then what we are going to do? Just like fractions, we always do what? Simplifying, add, subtract, multiply, and divide. Once we understand how they behave, right? So, but before we started algebra, we need to talk about what is a term. What is an item, right? We have to differentiate which is which, what is what, before we can manage that, right? So we define what is a term. We say a term is what? A product. What is a product? Multiplication, right? And or what? Quotient. What is a quotient? Means division, right? A product and a quotient of what? Bunch of things, right? Bunch of numbers and or, right? Variables raised to powers. Let's see, what do they mean, right? Or a single number or a single variable. What do you think? Can you give an example? Okay, sure. If it's a single number, okay, say 7 or minus 11, are those a single number? So it's one term, right? How about a single variable? So if I say x, is that a term? Y, is that a term? Right? And how about this one? A product or quotient of bunch of things, numbers and variables, raised to powers. So, if I have 5x, is that a term or two terms? A product. So it is a term, right? So if I have 5x cubed, numbers, right? Product of numbers and or variables raised to a power. Variable raised to a power by itself, it's a term. Or I can multiply by a number, it's a term. Or I can have, okay, a bunch of variables, right? Raised to powers. Then I do the product. It's still a term, right? Or I can say, okay, by dividing them, which is a quotient, is still a term. But what kind of things is not just a term? Take a look. If I have 7x, how many terms I have? 1, right? If I have z, how many terms I have? 1, right? So if I add them together, what do you think? That would be 2 of them, 2 terms, right? So how do we separate the terms is by doing what? Terms are separated by plus and minus signs. So individually, each terms by multiplying or dividing. Then you combine them, it will become bunch terms. If we have this, 11 and how many terms I have? 1. If I have 3x squared, y, z, 5w, right? How many terms? 1. If I put a minus in between, it means what? 2 separate terms. They are separated by plus and minus. If we have this, 4x squared plus 15x minus 12. How many terms you think you have? That would be 3 terms. Right? Good? And we will, usually when we started to talk about things, we will do what? Introduce the idea and the names we use. We call it what? Vocabularies, right? And explain what they are. Then you can do better. And next one, we are on the page 12. We are going to talk about something called numerical coefficient. What does numerical mean? Some kind of numbers. Coefficient, sometimes numerical coefficient, we just say coefficient, right? Which is what? The number, the numerical part of it. Numerical factor of a term. Right? If like this, okay, 1 term, then which part is the number in front of variable 5? So that would be its what? Coefficient, numerical coefficient. So first we identify them, we introduce the concept, and we identify them first. Then we see how we are going to operate on them. Okay, we have this one, and what do you think your coefficient would be? So that's your variable. Coefficient is the number in front of it, -7, right? How about an n to the 3rd? How many terms we have? 1. What's the number in front of it? Which would be invisible 1, right? How about -y? That would be, right? And how about v over 4? What's the number before the variable? Is that same thing as what? Like this. If 1/4 times v, how do you multiply? Then, okay, so you put the 1 underneath, you cross, you multiply straight across, that would be this one, right? So, what's your coefficient? That would be 1/4, right? So, we introduce the idea, something called coefficient. Another thing, before we do algebra, and we are going to introduce something called like terms. You will hear it all the time. Like terms. What are they? What do you think? Like terms means what? They must be what? Alike, right? So they are exactly alike, but not quite, except the number part of it, okay? Except the coefficient, right? Can be different. Like you have 5 pesos and 7 pesos. Do you think they are same thing about pesos? Yes, except 5 and 7. So your coefficients are like adjective to describe the term, the variable you have. Okay? So if you take a look, it's a 7x and 5x same term, same type, like terms? Yes. Same variable. And if I have 7x and 5x squared, are they like terms? Not really. Because x and x squared are different. Just like if I have x squared here, x cubed here. Are they like terms? Not really. So like terms are what? You will have same variable and what? Same power. You have to have a same power. This is power 1, right? This is multiplied twice. Like square and the cubes, they are different things. If you look at the next one, x squared and y and 7yx squared, are they like terms? Yes, because x squared, y. You can write it differently by commutative property, but they mean same thing, right? Except the coefficient are different. How about this one? Negative 2xz squared and negative 6x squared z. What do you think? No. Why not? Because x here and x squared here. Z squared here and z here. They are not alike. Like terms are what? They have same variable and same powers. Okay, so we started to introduce the algebra. It means what? We will use all those terms, right? Like terms, variables, and what? Coefficient. Okay, we are on the page 12, right? We are doing the algebra now with what? Bunch of variables. So we say what kind of things are like terms and what kind of things are called numerical coefficients, right? Now we see how we are going to operate on them. And so we say numbers, variables, x, y, z, letters are numbers. So they behave like what? The numbers. With their properties. Okay? So let's take a look. We are going to operate on them means what? Add, subtract, multiply, and divide. Right? So how do we do? First, we simplify them. Then we combine them by combining, right? So simplify means what? Combine them. It's for what? Add and subtract. Then when things are alike, okay? By using what? By using the things we have learned called the distributive property, right? That's how numbers work. Same thing as a variable. So we are going to make things simpler first by doing so. Look some examples. It's like you have what? Pesos and dollars. If I have 5 pesos and $7, can I say how much pesos I have or how much dollars, how many dollars I have, right? So either you change pesos to dollars or dollars to pesos. Then you can put it together. There must be what? Like terms, alike. So first one, you have what? 9y minus 4y. What do you think you would do? You will, unconsciously you will think, oh, 9 minus 4 is what? 5. You will have 5y. So you already think about distributive property unconsciously, right? Not unconsciously, subconsciously, right? 9 minus 4 of y, so you say I have 5y. How about 11x squared plus x squared? That means what? I have 11, oops, not a cube. I have squares. I have this 11 of them plus 1 of the square. X squared means what? Invisible 1. What do you think? How many squares you have? You just add them. You have 12x squared. Right? Next one. And we have what? 5x squared minus 3x plus 6x. What do we do? Which two are like terms? So this is a square. This is just a simple x, right? So simple x, you can put them together. So negative 3 plus 6 is what? 3. So you keep your x's, right? X squared. Then this one will be what? 6. Oops, not really. 6 minus 3 is what? 3x. Right? Sometimes you get confused and with what? If I have, say, not on your paper, this one. If I have 5x squared minus 3, say, x cubed plus, say, 5x cubed. Which two are like terms? So square is a square, cubes are cubes, right? So you can only combine the cubes with cubes. And 5 and negative 3, that would be what? 2 of those, 2x cubes, right? Then the 5x squared remain. So if you do that, that would be your answer for this. So you don't mingle different things. Cube is cube, square is square. So same variable, same power, they are like terms, right, with those. So next one, if you have 4m plus 1, how many terms you have? 2. Are they alike? No. So that would be your answer. Okay? Next one, if we have negative 7a minus 2 minus a plus 5, what do you think? A and A are like terms. -7 and -1 will be what? -8 of A. Then numbers, oops, right? Numbers and numbers are alike, definitely. So 5 and -2, you have 3. So that would be your answer. So what did we just do? We call it what? Combining like terms. If they are alike, we combine them, right? Next one. So we want to simplify things, make things simpler, and before we can resolve, right? That's how the approach would be. So take a look. If I have -3y plus 6, what do we want to do is we write individual terms without parentheses to describe each term. What do they look like, right? So if I have two things together in a group, I want to express them individually. So I will distribute my -3, right? So to remove parentheses. So what do we have? That will be -3y and -18. Okay? Look, the next one. If we have this, 3x plus 2y plus z minus 1, how many terms we have? 4 different terms. Then describe individually instead in a group. We need to distribute our negative, right? So individually, if you take away or you multiply by negative, everybody change the signs, right? So you will have negative times positive, negative, negative times positive, negative 2y, negative times z, negative z, negative times -1. That would be what? Positive 1. Right? So, in general, that's what we say. Okay? In general, we do what? To simplify, to write it simply, we write it individually. Okay, without grouping. Then, so we want to what? Remove the parentheses using what? Using the distributive property we just learned, right? When possible, we do that. Right? After that, we also need to do what? Simplify them by combining like terms. Put it together if they are alike. It's no reason to write the two same thing and together, just leave them there. You say $5, I have $5 and $3. Total, you just say, I have $8. Right? So we will combine like terms. Let's look more examples. We are on the page 13. We are going to simplify those expressions, right? What are expressions? It's a bunch of things, right? Math language. Expressions are those with an equal sign, right? So we just want to make things simpler instead of write a bunch of things there. So for this, how should we start? We want to write it individually first. So first you remove the parentheses, right? by using distributive property. So let's see what happened. Negative 5 times 2x, it will be, put your equal sign here, so you know you are working with together, right? From one step to another. So that will be negative what? 5 times 2, 10x, right? Negative 5 times negative 8, that would be positive 40. And next part, negative 4, positive 4 times negative 8, minus 32x, right? 4 times 7, positive 28. So each term, you have what? Signs in front of it. The sign goes with the term behind it, okay? So do we have like terms? X with x, right? So that will be negative 10 and a negative 32. That would be negative 42x, right? Number in number, 40 and 28, that would be 68. Are we good? So when we use X, Y, Z, it's just those are symbols, represent the idea of what? Numbers. But we operate in our head, okay? So 3 times 2x plus 1 minus 5x minus 1. So first you remove the parentheses, then you combine, right? So we distribute them. 3 times 2x, 6 of those. 3 times 1 plus 3, right? And negative distribute to both of them, negative and 5x minus 5x. Negative on negative 1, change, plus 1, right? Do we have like terms? Yes. 6x minus 5x, that would be what? One of those got 1x. And the numbers, 3 and 1, that will be your 4. Right? Manageable, right? So, algebra is not that hard. Just connect those symbols, abstract concepts, with whatever you can think of. Okay, so for this one, this is a multiplication, this is a subtraction, right? Of course, we do what first? Multiplication. So 8 is 8. Then you will distribute 5. Minus 5, it's the same thing as a negative 5. So you distribute them. Negative 5 times 6y will be what? Negative 30y, right? Negative 5 times negative 3, that would be 15. Then we'll combine like terms. Y is y by itself, negative 30y. And numbers 8 and 15, that will be 23. That will be your answer. So this is on page 13. That's our section 1.9. Okay, we talk about what? How numbers behave and how we will handle the variables and something called terms. Then we are doing what? Simplifying your terms, right? So first we make it simpler, and later on we are going to do what? And subtract and multiply and divide. Okay, that will be this section.